All right, welcome to class. Our goal is to quickly go over Chapter 8, which is Numerical Python. How to do matrices and arrays in Python. So Numerical Python is a very powerful library of Python. It can handle n-dimensional arrays, which are basically matrices and tensors. It's fast. It has a lot of numerical computational tools. It supports a wide range of hardware. It's written to be extremely efficient using well-optimized C code. It's easy to use, and it's open source, which means anybody could get the source code and change it to their needs. So let's start with arrays. So I'm going to copy and paste these 5 lines of code here, and let's run them. And we didn't do much, but what we did do is we converted 2 Python lists to Numpy arrays. So the first array is an array of integers. It's of type int64. And the second array is of type float, float64. This means these are 64-bit numbers. You're using a string of 64 binary numbers in order to represent these. Now, if we want to see what these objects look like, we can say print A, print B, and you can see that they basically look like Python lists, but the difference is that the array is probably like 1,000 times faster to use in an application. So it's much more efficient to use that. All right, next we're going to create a 2-dimensional array. So a 2-dimensional array is known as a matrix. So let me get rid of these statements here. Let's see what C looks like. So it's basically a list of lists when you print it out like this, but it is a matrix. It's a 2x3 matrix. And in fact, you can access each entry like you would in matrix notation. So let me try to print a few of these. So print C2, print C12. Okay, so notice 0, 2, that's row 0, column 2. As in Python, we always start counting at 0. So this would be the 0th row, and 15 is in the 0th column. So our columns are 0, 1, and 2, and our rows are 0 and 1. So 1, 1 is row 1, column 1. Remember, we start counting at 0. So that gives us the, that would be the number 5. 1, 2 would be row 1, column 2, which is really the 3rd column when you start counting at 0. And as we predicted, it should be 6. All right, so that's the basic idea of how you can input a matrix. Now, sometimes you want to input a matrix but not have to worry about typing in every entry, and there are methods for doing that. So, for example, you can create a matrix of zeros with type float 64. So these are floats. You might say, why do we have this float 64? Python is not picky about the data type, but that's what makes Python very slow. When you specify how big your numbers can be and how precise they can be beforehand, the compiler can optimize things and really speed up your code. So that's why you're stuck within a type once you initialize an object. That makes your program run much faster. All right, and let's print out. Let's see what this looks like. If you leave this as the last line of code, it'll automatically print it out. So this is an array of this form. Notice it's a 3 rows by 4 columns, but we do start counting at 0, so it's really 0, 1, 2, 3 for the number of columns, and the rows are 0, 1, and 2. If you'd like to make a matrix of ones, you can do it like this. So let's say B is equal to, and then let's print B. So notice when you print, it leaves off that array word that was displayed before. In fact, it's often very useful to create matrices with random numbers in them. Maybe to test out a model of some sort, you need random numbers filling up a matrix. So let's try this out. So NP is our library, of course, our Numpy library. We're using its random sublibrary, and inside it, it has a function called rand, which will give us a random number, a random 3 by 3 matrix. So this one line creates a random 3 by 3 matrix. So let's see what it did for us. All right, so let me get rid of some of the previous print commands. Clean up a little bit. All right. Okay, so this is the matrix X right here. And this is the matrix Y. All right, so we have 2 matrices. We have 2 matrices that we can now work with. Okay, one of the most important things with matrices is to multiply matrices. So to multiply matrices using Numpy, you use the dot command. So np Numpy library period dot. So let's use the dot function, and it takes the dot product of the matrices X and Y, and let's print out Z, and let's try it. And there you go. There is our there's our product. See, and Numpy is fast. See, let me get rid of these print commands and show you what happens when you use a huge matrix. 300 by 300. 300 by 300. So let's say we run this with a 300 by 300 matrix. I think it finished. So let me put a marker. print done. All right, so let's see how long it takes. See, that's it. It generated two big matrices and printed them. Let's say we had another 0 here. And remember, 3,000 by 3,000 would have 9 million entries, right? So those are big matrices. So it took a few seconds, but if you tried to write code by hand to do this using a nested for loop, more like a triple for loop in Python, I think you would notice that it would take quite a bit longer, probably in the minutes, if I had to guess, rather than the seconds. Okay. All right, so we know how to multiply matrices now. Okay. Now, there is another type of multiplication that you want to be careful you don't confuse with. So let me go back to small matrices so we can display them. Don't try to display such a huge matrix, it'll probably crash Colab. All right, so let's say instead of, let's say instead of Z, we do W equals X times Y, and you print W. This is not matrix multiplication. It looks like it, and it looks like it should be, but it's actually called the hadamard product. And it's the way that you multiply matrices the first time you attempt it on your own, which is wrong, which is component-wise. For example, you'd multiply every entry by its corresponding entry. So this hadamard product would be something like this. Say 1, 2, 3, 4, with a dot, 5, 6, 7, 8. So the hadamard product would be 1 times 5, which is 5, 2 times 6, 3 times 7, and 4 times 8. Now remember, this is not matrix multiplication, it's hadamard multiplication. So it's not the one that we usually use, though it is used in machine learning, in neural networks. So it is useful. It's just not what you usually do when you multiply matrices. Now, of course, if you want to add and subtract matrices, there's only really one way to do that. So you can add and subtract matrices just using the plus and minus sign. All right, so the following exercise, we would like to construct two 3x3 matrices with random integers in an interval from -10 to 10. Then we would like to use a double loop to compute the matrix sum, C equals A plus B. Use a double loop. I think you actually might need a triple loop in there somewhere to compute the matrix product. And then use Numpy's built-in functions to do this. So let's take a look at this program and go through it. All right, it looks like I missed the first. Looks like it didn't copy and paste correctly. Let's see. Oh, no, it's here. All right, we're good. Sometimes it doesn't copy and paste totally correct, though. So let's fix it. All right, this one would have to be indented. Remember, we always indent within a loop. All right, fixing this program. Okay. right, so we're going to, by hand, create two 3x3 matrices with integer coefficients. Notice they start out as zeros. Then we're using a nested double for loop to fill each entry with a random integer between -10 and 10. And then right here in line 9, we're using the Numpy built-in procedure for adding on two matrices, and the Numpy built-in procedure for multiplying two matrices. What would be a good exercise for you to do is to actually do these without the Numpy exercise, the Numpy library. So write the code that would get you the sum of two matrices, and try to write code that would give you the product of the two matrices. All right, let's run this. All right, and here are our answers. See, we have our matrix A, we have our matrix B, and C is the sum of the two matrices. You can check that it's correct. And D is the matrix multiplication, matrix product. All right. One really neat thing about the Numpy library is you can use it to make really neat graphs and plots. So this is just a little bit of extra information for you. I'm not going to test you on this, but I just wanted to bring your attention to it. So what are the uses of a multi-dimensional array? Well, one of them is for graphics. So let's take a look at these three graphs. Here we have the typical cosine function. Here we have what's called a parametric curve with scatter. So parametric curves are these curves in 3 dimensions, and think of it as a trajectory as a function of time. For each time, say in seconds, you get a different set of 3 coordinates. And if you plot those, you actually will get a trajectory like this. So this is called a parametric curve. Now these scatter things around here are random data points that are sort of oscillating around your parametric curve. And finally, if you take multivariable calculus, you learn how to study some higher dimensional graphs. This is a surface in 3 dimensions. And, I encourage you to maybe type in these, copy and paste these, this code in order to generate these plots. So the idea is you need a 3-dimensional matrix, a 3x3x3, in order to hold all these coordinates. And then Python has built-in libraries that are able to generate these nice 3D graphics. All right, so I hope you enjoyed Python and continue to learn this in the future. It's very useful, and take care, everybody.